The core of the sun burns at 15 million Kelvin. Under classical physics, that temperature is a mathematical contradiction. It is actually far too cold for a star to operate. To understand why, we have to look at the subatomic mechanics of a collision. Protons carry a positive electrical charge. When two protons approach each other, they natively repel one another, acting exactly like the opposing poles of two magnets. This chart models the Coulomb Barrier, the massive, exponentially scaling electrostatic firewall two nuclei must climb to touch. Plotting the sun's 15 million degree limit onto this curve reveals the problem. Solar heat falls drastically short of the peak energy required. The harder the universe pushes those protons together, the more violently the electrostatic force repels them. If classical collision physics were absolute, the Coulomb barrier would be an impenetrable wall. The protons would bounce off each other infinitely, leaving the sun as a cold, dark, and dead sphere of gas. But the sun obviously burns. The flaw in that rigid mathematical model is treating subatomic particles like solid physical billiard balls. This diagram illustrates the wave function. A particle is not a fixed point, but a smeared fluid wave of potential locations. The density of this distribution overlay dictates the statistical probability of where the particle will ultimately be rendered. When this probability wave impacts a classically impenetrable boundary, it does not experience a hard geometric stop. Modeling the architecture of reality requires relying on these statistical probabilities, rather than deterministic physical contact. At the exact boundary line, the probability wave actually bleeds into and slightly past the solid geometry of the barrier. Physicists like Hans Bethe relied on this exact quantum behavior in 1938 when he mapped out the proton-proton chains that dominate stellar cores. Because the wave bleeds through the wall, there remains a microscopic, non-zero probability that the particle will simply render on the far side of the barrier. This is quantum tunneling. It is a phenomenon where a subatomic particle instantaneously teleports past an impenetrable potential energy barrier without breaking it. Quantum tunneling overrides deterministic laws. It acts as an error in the collision detection of the universe, allowing a mathematically impossible outcome. This recontextualizes the sun's 15 million degree core. While that temperature cannot classically breach the firewall, it serves a different purpose: violent acceleration. Inside the solar core, the physical density of the protons is extreme. They are fired at the firewall at raw, chaotic speeds. This forces an unimaginable frequency of localized subatomic collisions to happen simultaneously. This scatter plot shows the scaling effect of those conditions. Because the collision frequency is so high, the infinitesimally rare statistical anomaly of quantum tunneling successfully triggers billions of times every single second. The graph also tracks the immediate result. The tunneled nuclei successfully combine to form a larger nucleus. This is nuclear fusion, a reaction that releases the slight difference in their combined mass as pure energy. That continuous cataclysmic energy release acts as the definitive engine of existence, providing the light, heat, and raw power required for biological evolution. The sun shines and life exists solely because the physical codebase of the universe contains a microscopic collision flaw.